Everyone, this is Advent of Code and we are solving day 5 of 2024. So today we have given a problem where we have some rules and some number of pages, a list of pages, and we want to check if those are in a specific order following the rules. So if you would see, there are two sections in the input. The first one showing out all the rules that are mapped as a page number, and the associated page number that should be before that page number. So if we consider here, 47 should appear before 53, 97 should appear before 13, and so on. So these are the rules in the first section. And if you see in the second section, there is this list of numbers or page numbers, and those are, I would say, a list of inputs that we need to check out following the rules. So if any of the pages in this individual list is not following any of the above rules, then we say that this particular uh, update is not following the rules, so it is not in the correct order. So that is what we want to have, and once we know that this update is not in the order, we need to make sure that we only add up the updates which are following the order, and we add up the middle page numbers for the correct ordered page updates, and that is the score for part 1. So you can see here we get out the score as the middle page number, and so that is for part 1. So I'll explain in a little bit detail. So you can see over here in the inputs we have been given this list of page numbers for like separated by like slash uh, or symbol. Then so these are a rule. So if I map it out, it would look something like this. So 47, 53. So you can see 47 appears multiple times in the single row. That is, one number can be have a rule that should allow it to come before some number of pages. So it could be multiple pages as well. And you can see 47 is appearing multiple times here. So if we construct a list or a map, or let's say each of the numbers here are representing the numbers on the left hand side, and the numbers on the right hand side are the numbers that should be appearing before that particular number. So if you see, 29 should appear before 13, 47 should appear before 53, 13, 61, 29 if they appear in a single update. So let's take an example that will be much clearer. So if we take 75, 47, 61, 53, 29, in this case we need to check for each of the numbers. So let's say we take 75 because it's the uh, first number. We don't have to check anything because it is the first number and nothing can appear before it. So let's check at the second number, which is 47. If you see 47, there is just one number before it, 75. And if you see the rules for 47, 53, 13, 61, 9 should appear before 47. But here it is uh, not the case because 75 is coming before it, but 47 does not have a rule that says 47 should come before 75. So we consider this. Okay, then we move to the next example, that is 61. That is the next number in the page number in the update, 61. If you see, there are 75 and 47 before this. If you see here, 61 has a rule that says 13, 53, 29 should come after 61. And in this case, there are no matching values here, so we say 61 is also fine. And then we move to 53. And you can see 53 has a rule that says 29 and 13 should come after 53. So 53 has 29 after it, so that is fine. And 13 is not before it, so it's also fine. And we can see 29 here. So 29 comes, 29 has just one rule, that is 13 should come before, come after it. And there's no 13 here, so it's fine. So we mark this update as correct. So this is in a correct order. And so we just take the middle element, that is 61, and you would see that that is the instruction that we have given. 61 should be considered for the final score of this update. And next, let's take the example where the update failed. So I think it is the second or third. 97, 61, 53. Okay, so that is correct. 75, 29 is also correct. So let's take out the last, third, fourth example. Let me scroll this a little. So if you see this example here, let me copy it. Let me copy it here for a better visualizations. So if you see 75, 97, 47, and 61 and 53, these are the five numbers that we have here. And we start from the second element, that is 97, and we see the rules for 97. And you can see here 13, 61, 47, 29, 53, 75 comes in this list. And so 97 appears after 75, which is not in the correct order, because 97 should come before 75. That is the rule for here. And this has violated the rule, so we consider this as the update in the incorrect order. So we have to mark this order, this update in the incorrect, as a incorrect order. So the rest of the values are correctly ordered. So let's take another example. So all of these values are incorrectly ordered. We can see because 29 over here, 29 has a rule that says 13 should come after it, after 29. So that is violated because 13 comes before 29. So that is also incorrectly ordered. Let's move to the last example. So if you see here 13, if you see the first element, that is the second element, sorry, 13 element, 13th number, page number, it has no rules in this, so it is fine. And 97 has rules like 13 should come after it, so that is fine as well. But we usually don't check the first number. So let's take a look at 75. And if you see 75, it has rules for 29, 53, 47, 61, and 13. But 13 has appeared before 75, so we need to mark this invalid as well. So even if we see one number getting out of order, even it not following one of the rules, we have to mark the complete update as not in the correct order. So that is the problem for day 5. And in the first part, we just have to calculate the score, that will be the middle element which are correct ordered. We just take the middle element of the update and add it up to get the final score of the part 1. So let's see how we will approach this. So what we could do is simple, that we will construct this map, like it will be a list of numbers, and each number will be a list of numbers. So it could be a map of list along with list of integers, and each integer will have a map of list of integers. So we are mapping integers with a list of integers. And what we will do with this map is this will act as a rule book, and will try to uh, apply these rules in for this particular update. And what we need to check is we start from the first element, that is 0th from first element, and we check for all of the rules. And what we could do here is we could create a list of indices. So let's say where, so for all the rules here, we could create some sort of index, that index is a list of integers that could represent where all 75 exist in all of them positions. And if we see 75 appears here, and if you see each of the elements in this map as in this list, so if you see any of the numbers are occurring before that index. So we will have so what we will have is let's take a simple example here. So we have 75. Um, so I will have a complex. It's not a complex, but a simple structure. But it will have a lot of values. So I'm not writing the whole thing down. But let's say I have one number with a list of indices where it appears in the all of the updates. So in the first case, it is zeroth index. In the second update, it doesn't exist, so I keep it -1. In the third update, it appears in the zeroth position, and in the fourth as well, it appears in zero. In the fifth, it doesn't. In the sixth, it appears at location two, index two. So I will have this kind of map. And next, so let's take a look at this example. So 17 and 13. So let's take a look at 13 here. And if we see 13 is appearing, it doesn't appear in the first list, first update. It appears at the negative. So it is 1, 0, 1, 2, 3, fourth position. 13 it is at second index. Then it doesn't appear here. It appears in the first index and it appears again in the first index. So now, if we take this example, which was like had unordered, like it is not in the correct order. So we will why it was not in the correct order, because if we see 75 has a rule that says 13 should come after it, and if we compare the 13th, like if we compare the index for the last page, if we would see that 75 has index 2 when 13 has index 1, which means 13 comes before 75. So that is why the last update is out of order. So that is how we will try to approach this part 1. We will just create a list of indexes for each of the numbers that appear in the rule, and with that we can just easily compare which numbers are before and after, and applying that rule we can see that that will be used to identify which are in the correct and the incorrect order. So let's get started with the code. So what we will do first is just sort of create a boilerplate. Let's leave this section. So I need to construct this function that will be used to uh, read sections. Like there are two sections. So the first one is rule and the second one is the list of updates. So I'll need to create this function that will just take in the input file and give me sections that will be two parts, the rule and the list of updates. So I'll construct that, and so I need to construct rules as well. That will be a map or a map of integers with list of integers. So we'll construct that. We'll pass the section 0, that will be a list of lines for the first section. It will be a string representation. We'll see in a second, and what we'll do is we'll set the pages that will be the updates in the section 1, that will be the second section, and we will get page indices. That is what, like I mentioned over here, that we will get uh, individual numbers along with wherever they exist in the updates. So we will pass in the rules because we want to construct only the numbers that appear in the rule and not for every number that exists in the page order in the updates. And we also pass in the pages because we need to check where the number exists in the updates pages. And once we have that, we will just call the function that will be get ordered pages, that will take in the page indexes and the rules, and also it will take the pages because we want to iterate over all the pages and check which is ordered and which is not ordered, and compute the score accordingly. So that will be used to get the score out of this indices and updates. So that is the like step by step approach. Now we need to construct individual functions. So first we'll create read file sections that will be taking the path and will return. So now we need to think about the data structure. So here, uh, so there are two sections here. So that definitely there will be two elements. So there will be a list. Then we will have individual list for all the rules. So it will be another list, and inside of that also we will have another list because this is list, right? So if you consider this two elements, there will be just two elements in the first list, 0 and 1. That will be the first will be the rule, and second will be the page updates. And the next list, so inside of the uh, first list, so let's say this rule, it will have a list because this there are multiple rules. There are list of rules. So we need to have list of integers, right? And once we have used that, we'll just create a read file back that is just loading in the raw bytes from the file. This is a helper function that I've written for the past all the AOC problems. So we'll just create a list of strings and then we need to separate it out on the new line. So that is two new lines. So it will be separated for the two sections. Once we have that, we'll split the bytes on that separator and we'll get the line. So that won't be a line, it will be a section. And for each section, we need to check if it's not empty. That will be edge case for the last line. And once we have that, we append that string into that lines. We are just constructing the string for easier purposes. Then we'll iterate it over all the sections. So once we have that lines separated into sections, we just iterate over all the lines using the sections, and we'll create a list of integers. So this will be one section will have like a list, and that list will have a single rule. So rule can have two numbers, so that's why we are using a list of integers. Similarly, for the page updates, that will be a list of multiple numbers, so it is a list. So we'll split the section on new line because there are multiple uh, lines, updates or rules. So we need to split it on new lines. Once we have that, we need to uh, now use a separator because that separator will be kind of different. So here you can see the separator for the rules is like a standing slash, whatever it's called, and here it is comma. So that is, I'll keep it default as comma, and if the section we are in the first section, we'll update the separator to or operator. I call it all operator or operator. You can call it standing line, whatever. Uh, so now we need to iterate over all the line strings that we have splitted on new lines. And once we have that string, we need to we don't need we don't want the empty string, so we just continue that. And we need to now create a list of integers. We'll split that line string into separators, so that this separator will be now used according to which of the sections we are in. And once we are there, we just split it out and we'll get a list of strings. So we'll iterate over all the number strings and we'll convert that string into integers, and that's how we will have the list of integers, the first list of integers, and then we'll append that list of integers into the nums that we have used for individual uh, lines, updates, or rules. And once we have that, we'll append it to sections because we have two sections and we need to append it individually into sections. So this will construct a list. This will construct a list. This will construct a list of lists, and this will construct a list of list integers. We'll return sections, and now we need to construct the rules. So this is very simple because we just need to separate it out, and we need to construct a map of integers and list of integers. So we'll create a map with the key as integer and values as a list of integers. That will be the numbers that should appear after that number in that map. So we'll iterate over all the rules list. That will be uh, a list of integers. So that is how what we have constructed just right here. and we need to iterate over all of them. And once we have that, we'll take the first element. So you can see here, the first element is the number that should appear before appear of like before this number. So 53 should appear after 47, and 47 should appear 53. However you take it. So I'll take the first element in that list and append it. So this will be the map constructed, and the elements will. So I will append that uh, rule one, that is the next the first indexed number into the list that I'm constructing for this individual number, right? So once we have this number, we'll just append it. It will keep on appending for the numbers because there are multiple numbers for this. So once we are done, we just return the rules. Now we need to construct get page indices that will be used to grab all the numbers from the rules. And for each of the numbers in the rules, we need to construct the map on map list of indices that will be present in the update, in the list of updates. So we'll take the rules that will be a map of integers along with the list of integers, and we'll take in the pages that will be a list of integers, and we'll return a map of integers that is for each of the numbers in the rules along with that mapped in the list of integers that will be mapped to the list of indices. So that will be mapped with integer with our list of integers. So we'll start by creating that map integers with a boolean. Let's say it is a boolean for now, because we just need to check if. So we are first constructing a list of integers, or you can say map of list of integers, which will hold the unique numbers in the rules. Okay, so we'll iterate over all the rules, and we will construct the map with that number, and we'll set it to true. And for each of the list that is in the list of the rules. So remember, we have constructed this uh, list of integers. So we also need to iterate over all of these numbers and create a map for them as well. So if we see that number element doesn't exist, we need to set it to true as well, and we'll. So at this point, we will have nums as a map, but the keys will have the unique numbers that exist in that rules. So now we'll create the actual map integers with the list of integers that will be used to represent the indices for the individual numbers. Once we have that, we'll iterate over them, and we need to iterate over the pages because we are looking for all of the pages, correct? And if so, what are we doing here is we are taking all the numbers that exist in that in the rules, all the numbers in the rules, and we check if uh, for individual uh, page updates, we are checking if any of the numbers exist in this rule or not, and if those exist, we need to compare the indexes for that particular update index, correct? So once we have we'll set the index as -1 for now because we have not found that number. So we'll now need to iterate over num line. So now what was num line? That is the so pages. You can see it is a list of integers. So we need to iterate over them as well. Once we have that, now n will be the individual update page numbers in the update in that particular update. So if we check if on n equal to number, that is, we have found that one of the rules that is set in the rules book. It is there in that update. So we need to check that. We need to append that to the index. So we'll set that current index in the number line. That is the page update. We set that index to the to that page update that we are currently iterating for, and then we set that number indexes. So num indexes will be, yeah, that is the return value for the functions. It will be a number, so it will be a map for integer with list of integers. So for, let's say, for 75 it should be 0 for the first number. So we will append uh, that into the list for this particular number as the index. Once we have that, we just return that. So that looks quite short, but it does a lot of things here. It does the major pulling of the logic, that is we are just appending numbers, the indexes for each, for individual numbers in that rules. So once we have that, we need to construct this major, that is the main logic, that is get ordered pages. So we'll take the get ordered pages, which will take the rules, number of indices, that is the map with integers along with list of integers indices, and so that is the type. And we also need to pass in the pages because we need to have that update, list of updates. We need to do it update wise update. We need to do it uh, update by update, that is one update at a time. So we need to iterate over all the pages, that is updates, and we'll return the score, that is will be a single integer value. So we'll iterate over the pages and we'll grab the index and the page line. So page line will be the entire uh, list, correct? So we are iterating over all the pages. So page line will be the entire list, and we first set the order as true. So we assume that order is true when we'll set it false if we found any discrepancy. So we'll iterate over all the numbers in the page line. So that will be considered as number one. Number one. So that is the number that appears in the first in the list, and we need to check for all the rules that belong to that number. So we go through all the numbers in the list and we check for each of the numbers in this update. We can skip the first element, we know, but let's keep it simple. Just iterate over all the numbers and check for, but for all the numbers, that if they exist in the rule, we have a map, right? So we can just access it with a key, that is 75. 75 grab this, and with that we have a list of numbers that we need to check before this number. So if any of these numbers appear before 75, that is, their index is less than the index of 75 for that update, we set that update as unordered, right? So we grab that number one from that rule. So we'll have the rule list, and with, so we need to grab the index, right, for that number. With that rule, we just grab the entire list of numbers that belong to that numbers. So index one will be index number one and the index, correct? We can just use index, but that is how we will be using number indices, right? So we need to iterate over all the rules for that number and grab that index two. Now index two will be the number indices, that number num2. So for that rule, num2 and the index for that. So let's explain that. So let's consider this last update. You can see 75 and 13. So what we do is we first iterate over all of the numbers. So let's say we are at 75 and we check. So we grab the rule for 75, and now so we'll have this as rule num2, right? And we'll iterate over all the numbers in num2, that is 29 and 53, 47, 16, 13. So we'll hit at 13 and we see 13 here, but our number indices, so how we grab that is num2. So that is the element that we are iterating over the rules, 13. And how we'll get the next, that is index. So what position is uh, the page update on? So index will be the last position, right? So we are at the last position, so we'll grab one here because we are at the, so this, the length of this is equal to the page number of page updates in this list of page updates. So we grab the last element and we check we have index 1 and index 2. We just compare if index 1 is equal to minus 1, or this is just a guard check. If both of them don't exist, we just continue. But if index 1 is greater than index 2, we say that order is false. And if the order was true, then we update the score with the page line. So we grab the page update and we take the middle element by dividing the length by 2, and using that index we grab the score. So that is it. Sorry. So let us run that, and you can see the answer is 143, which is um, the expected output for part 1. So that is how we implement part 1. That was a little bit long, but that is the major thing implemented for part 2 as well, because part 2 requires a little bit of careful planning for part 1. So we have covered a lot of things here, and let's recap it one by one. So I'll create the file sections. That is, we split the input into two sections. That is, first for rule and second for the page update, list of page updates. And once we have the rules and the page updates, we construct this page indexes. That will be uh, like a map, not like a map for the numbers that exist in the rules. So all the numbers that exist in the rules with a list of in this list of integers, that will be the indexes for the numbers that are in the list of page updates. And once we have that, we just iterate over all the pages, the page updates, and for all of the numbers that exist in that page update, we grab the index for them, and for each of the rules, that is a rule number. So the numbers that exist for that particular number in that rule map, we need to iterate over them, and we need to check the index is uh, less than the index for that rule number. And if that is the case, then we continue. If that we have found that the order is mismatching, that is index 1 appears after index 2, that we need to set the order as false, and we just continue it till for that. But if we have completed the pages, so if you see here, we have completed the iteration to the page update, and now if we see that order is still true, we'll just update the score with the grabbing the middle element of that uh, page update, and just return the score at the end of all the page updates. That is from part 1. So for part 2, we have to update the incorrectly ordered updates. So we have to sort of shift the page numbers for the update that was incorrect in the first part, and now we need to add up the scores for that incorrect ordered pages, but after correcting them. So what do I mean by correcting them? That is, let's say this example, simple example, 61, 13, 29. We know that 29 had a rule for 13. It should appear 13 should appear after 29, but in this case, 16, 13, 29 was 13 was coming before 29. So we need to swap out 13 with 29. So how we will approach this, right? So that is the problem first of all. So we just swap out 29 with 13, and that becomes the correct order. And now we need to update. We need to add up the scores for the middle element after updating that page update. So that will be the part 2 score. And now let's see how we will approach this uh, part 2. So we have the numbers that are. So we have the pages page updates which are incorrectly ordered, because we have set it. We know that condition that when it fails. So when that happens, now we need to take that page update and check if which of the numbers in that update are are not following the rules. So what we will, let's say for example this one. So 97, 13, 75, 29, 47. In this case 75 and 13 are the discrepancy as we saw here. So 2 and 1, the index was coming before it. So what we will do is, so let's take the example for this one. So here you can see 97 is appearing after 75, which is violating the rule here. What we will do is we will take in, so we'll follow each of the rules. And if you see 90, so for 75, if any of the numbers, so for 75 it will be safe. So we will place first 75 in the new page update, the new page ordered update. And now we see 97. So 97 has index. So we would see that 75 is appearing in the list before 97. And we know that 75 doesn't, 75 is in the rules rules list. So we need to place 97 before 75. So what we would do is we would keep track of the indexes that are there in this original page update that we have appended it to. And now we need to shift that element to that element. So we will say 70, 95, 97 and 75. Okay, and now we move to 47. If you see 47, 53, 13, 61, and 9. None of the numbers are appearing before 47. So we just keep on moving ahead. So now we have 61. So we'll place 47 as well here. And now 61 has rules for 13, 53, and 29. So none of the numbers are appearing before 61 in this case. So we'll just place 61 as well. And then 53. So 53 has 629 and 13. None of the numbers are there in the page update. So we'll just append 53. So that is the correct order for this 97, 75, 47. And then let's take example here. We already have it. So now we'll check for 97 and we'll just place 97 by default because that's the first element. Then we take a look at 13. 13 doesn't have any rule for it. So we'll place 13 here because it doesn't have any rules. So we now move to 75. Now we check 29. Okay, 29 doesn't exist in the list. 53, it also doesn't exist. 47 exists, but it is not appended yet to the new list that you are creating here. 61 doesn't appear in the page update list. 13 appears in the list and it has been already appended. Now we keep track of this index, right? 13. We need to append it after 97 but before 13. Just before the element that caused this discrepancy, not at the way beginning of it, and not swap that element as well, because there will be elements that could cause. So while iterating the while solving this part 2, I just thought of swapping out the elements, but that won't work because there will be a particular case where uh, you will come over the same iteration again, and that will cause some other issues to other rules to break in that case. So we append 13. Sorry, we append 75, but before 13. Now we have 97, 75, 13, and let's move to 29. So 29 has a rule for 13 should appear after 29. Now we have updated the list by updating 75, but now we have updated the 13th index as well. So we need to come before 29, 13 and append 29 here. So now we move to 47. So 47 has elements 53, 13, 61, 29. 29, 13. So we would first append it to 47, but we saw 29 as well. So we move 47 here and we move 47 right here. So that is the final list, right? And it's 7, 75, 47, 29, and 13. So if you would see it with swapping it out, so if you let's take that example as well. So let's say that was 97, 13, and so again we first say 13 and 97. That is fine. Then move to 97, 13, and 75. So in that case, what we would have to do is we will take 75, keep 13 as it is, swap off 97, and move to 29, and keep 47 as it is. In the second iteration, we have moved 97, so we move to 29 and 29, 13. So 29, so we need to swap that as well. So we say 79, we swap out 29, keep 97 as it is. Here will be 13 swapped out, 47. And now we move to 47. So 47 has 13 and 29 in it. So you will first swap out with 13 first. So 97 and 47, 13. But we also saw 70 and 47 here. 13 and 29 there. So we'll replace this with 29 and 13 as it is. But you see the problem here. We need to again iterate over here because 97 has rules that we have already checked out, and now we need to again do it. But that will be quite expensive because we need to do it for all the elements again. So that is one approach as well, but that is a little uh, complex, or not complex, but quite iterative and quite repetitive, I would say. So that approach I didn't take. I took initially, but that went pretty bad pretty soon. So yeah, that's what I have approached in this part two. So let's see how we will implement this in Golang. So the part two, we will create one more function called get correct ordered pages. So uh, this was just ordered pages that were by default correct ordered. Now we need to say pick out the elements that are incorrectly ordered in the initial page updates and correct them if they are incorrectly ordered. So we'll return the same score. This will be score 2, and we'll take in the rules, page indices and pages that will be the same. Now we print score 2, and now we need to create this function get correct ordered pages, which will take in the rules, the numbers and map of integers with the list of integers that we have already constructed. The pages will be a list of integers and will return the score. So for each of the page updates, we will iterate over them, and we just do the same stuff that we did it for part 1. That is, we iterate over all of them and we check for the indexes. So we grab the first index and we grab the second index, that will be for individual rules in that for that particular number. And once we see that index exists and it is like coming after index 2, we see that order it is in incorrect order. And now here, instead of is ordered, for part 2 we need to check if it's not ordered, and if that's the case, then we need to call a function called correct page order. So this function will take in that particular page update and all the rules, and create that new page update. And once we have that newly updated page update, we append that score that will be the middle element of that newly updated page update and return the score. So we need to construct this correct page order. So what this will do is we'll take in the page update, that will be the list of integers, and the rules, that will be map of integers with the list of integers, and we'll return list of integers because we need to create a new uh, page update in the correct order. So we'll create a new page line update that will iterate over all the elements in the original page update. We'll create a map This will be used for creating the index for the appended elements in that new list, new page update, and we'll iterate over all the number that we have created in this new line. So initially it will be empty, but as soon as we keep appending to the new line update, we will update that index. So that is how we will update that index. So you can see this is a list of sorry, map of integers with the index. So for that number, that n in that new index, we'll keep updating the index that we have added here. And so new insert index, that will be uh, at the very end. We try to append it at the very end, but we need to check if we need to follow the rules. So we'll follow we need to check for all the numbers in the rules if that follows the criteria. And if the newly inserted index was greater than the index, we swap out with the index because we need to append that before that. And once we have created that, we need to sort of append that number, not to swap. We need to uh, create the slice before that number and append that number into that and append the remaining second part into the newly created index. So I grab the newly created index before that part. So everything after this index, I will create in a copy and I'll append that everything after. So like everything before that newly inserted index and append the number. So in this case, uh, if you saw, I appended 75 before 13, right? So 13 will have an index. So let's say 1. I append everything. So I append. So before 1. So before 1 that will be 97. So it will just 97. I append 75 here, and I have a copy of 13. Everything after 13 as well as 13 into a slice called after num, and I'll append that after num into the new line. That way we'll have a new list. So what I'm doing, so this example will be a little clear here. Let's say, so we will initially, will some iterations will have this 75, 97, 75, 13. We see 47 here. Which was this example? This one, correct? Yeah. So we see 47 at the very end, but if you see the rules, there is 29 and 13 in the list. So we see that, so in the copy of this, we will have everything after 13 and 13 including itself into the list, and we'll append 47 here. So 29 will not be there currently. So let me do one thing. 97, 75, 29 and 13. So initially we will place 47 here, but since there are more rules to be applied here, we need to shift. So here, let's take the fresh example here. So we have the index for 29, right? And we have not yet appended 47 here. And if you see 29, uh, that will be index 2. So we'll take everything after before 2 and append 47 here, and everything after 29, including 29 itself, as 29 and 13. So that is the approach for this. That is what we are doing here, creating a copy of this because it will mutate after we have appended that, and we'll return the new line. So that is it from part 2 as well. Let's check this quickly. So it is 123, which is the expected output for part 2. So that is how we solve part 2 for day 5. That was pretty simple, but yeah, that is what we do for part 2. We just take the the page updates which are not in order and just correct them by keeping track of the indexes where we saw the discrepancy, and for now iterating over all the rules, we will create a just new insert index that will keep overriding until we see the least index. So this, as I mentioned here, 47 should be appended before 13 and 29 as well. So we will check that index is not less or greater than that index. So if that is the case, we'll decrement that index further. That is how we use this. So that is it from part 2. Hope you uh, understood the approach, and let me know if you followed any other approach in the comments or anywhere. Uh, Thank you and happy coding.